A couple more examples to look at here in 3.6, implicit differentiation. The first one I want to look at is number 28. We're asked to find y double prime by implicit differentiation. So we're just going to follow our nose here, and we're going to first find y prime, which again is the same as dy dx. So going through our equation, the derivative of x squared is 2x. Derivative of 6xy, well, we got a product here. 6x is the first function, y is the second function, so we'll take the first function, which is 6x, and leave it alone, times the derivative of the second, dy dx, plus the second function, which is y, times the derivative of the first, which is just 6. Alright, and then on to the third function, y squared. The derivative of that is 2y times the derivative of y, dy dx. On the right side we have the derivative of a constant, or 0. Let's get things squared away here. So I have dy dx times 6x plus 2y on the left, and that's equal to, on the right side, looks like a negative 2x minus 6y. And so dy dx is equal to, looks like negative 2x minus 6y divided by 6x plus 2y. Or a negative, let's see, let's factor out a 2 out of the numerator and out of the denominator. That leaves me with an x plus 3y. I factored out that negative also here and here over 3x plus y. And so those 2's divide to 1. We're left with the negative of x plus 3y over 3x plus y. Now this is dy dx, which we could also write as y prime if we like. Let me rewrite that. Alright, so now we want to find y double prime. So we're going to take the derivative of y prime. So we're going to take y double prime. That's going to be the negative of, well, we're going to use the chain rule here. I'm sorry, the quotient rule, because we have a quotient. So we're going to take the bottom, which is going to be 3x plus y, times the derivative of the top. Derivative of x plus 3y is 1 plus 3 times dy dx. I'm going to write that as y prime instead of dy dx. We'll just write it as y prime. It's the same thing. So there's bottom times derivative of the top minus the top, which is x plus 3y, times the derivative of the bottom. Derivative of 3x is just 3. The derivative of y is dy dx, or y prime. Alright, so all that divided by the denominator, 3x plus y squared. So there's the quotient rule with implicit differentiation. Alright, let's go ahead and simplify this numerator here before what we're going to end up doing is substituting in for y prime this quantity right here, which is what y prime is equal to. But we want to simplify it a little bit first before we do that substitution. So foiling out here, we have a 3x. The outer is going to be a 9xy prime plus y plus 3y y prime minus, let's see, foiling these two quantities, we get a 3x plus xy prime plus 9y plus 3y y prime. All of that over the quantity of 3x plus y squared, and we're taking the negative of all that, remember. Alright, simplifying the numerator, then we get that y double prime is equal to the negative of, let's see, we got a positive, let's see, just write this as 3x plus 9xy prime plus y plus 3y y prime. Distributing the negative here through the second quantity, we get negative 3x minus xy prime minus 9y minus 3y y prime. All that divided by our original denominator squared. Now we should lose some things. A positive 3x and a negative 3x. What else do we lose? Anything else? A positive 3y y prime and a negative 3y y prime. And let's see, we can combine a couple of things. So what do we get then? We get that y double prime is going to be equal to the negative of, here I have 9xy prime minus 1xy prime. That leaves me with 8xy prime. And a positive y minus a 9y is a negative 8y. All that divided by the quantity 3x plus y, quantity squared. Let's distribute that negative then. What we get is a negative 8xy plus 8y, sorry, negative 8xy prime plus 8y over the quantity 3x plus y squared. And so finally then we get that y double prime. Well, not quite finally, but we get that it's equal to 8y minus 8xy prime all over the quantity of 3x plus y squared, or 8 times the quantity of y minus xy prime over the quantity of 3x plus y squared. And now what we want to do is, in place of this y prime, we want to substitute what it's equal to. And remember what y prime was equal to was this up here. Y prime is equal to negative x minus 3y over 3x plus y. So I'm going to put that in for y prime, negative x minus 3y over 3x plus y. And so my y double prime is 8 times the quantity of y minus x times, putting in for y prime, it is negative x minus 3y over x over 3x plus y. That's what y prime is equal to. Okay, and then all that divided by 3x plus y quantity squared. Now I'm going to get rid of that denominator, so I'm going to multiply both top and bottom by 3x plus y. That'll just give me a 3x plus y cubed in our denominator here, but I'll get, let's see, I'll get 8 times y times 3x plus y minus x times just a negative x minus 3y, because this will distribute here and cancel with that, 3x plus y times that term there, and again in our denominator we're going to get 3x plus y quantity squared times another one, so quantity cubed. We take 3x plus y squared times 3x plus y. Alright, hang on here, hang with me, we're almost to the end. So we get that y double prime is equal to 8y times 3x plus y. Let's see. If we factor a negative out of there, it's going to be a plus 8x times x plus 3y all over the quantity of 3x plus y cubed. And let's see, can we simplify this at all? Y double prime is equal to 24xy plus 8y squared plus 8x squared plus 24xy. All that over the quantity of 3x plus y cubed. And so y double prime is equal to 8x squared plus 48xy plus 8y squared all over the quantity of 3x plus y cubed, or 8 times the quantity of x squared plus 6xy plus y squared all over the quantity of 3x plus y cubed. But if you recall from our original equation, it says that this is equal to 8. And so we just get 8 times 8, or 64, over the quantity 3x plus y cubed, and that is y double prime. Kind of ugly, but it all turned out pretty nice in the end. Alright, now let's just try a couple examples of taking derivatives of inverse trig functions. For example, 29, we have that y is equal to the inverse tangent of the square root of x, or we could think of this as the inverse tangent of x to the 1/2 power. Now remember, off to the side here, let's remind ourselves that if y is equal to the inverse tangent of x in general, that dy dx, based on what the book developed, the derivative of the inverse tangent on the bottom of page 237 is equal to 1 over 1 plus x squared. Alright, so now coming up here, we have that y prime is equal to, well, the derivative of the inverse tangent of something is going to be 1 over 1 plus that something squared. But then we have to multiply times the derivative of what's inside here. The chain rule is at work. So we have 1/2 x to the negative 1/2, the derivative of the inside function. So y prime is equal to 1 over 1 plus, well, x to the 1/2 squared is just x, times 1 over 2 times the square root of x, 1/2 x to the negative 1/2. Alright, so that's how you can leave that function just like that. Let's try another one of these functions. Let's try 32. We have h of x is equal to the square root of 1 minus x squared times the arc sine of x. Now, arc sine of x is the same as the inverse sine. In fact, let's rewrite this whole problem a little bit differently. Let's write it as 1 minus x squared to the 1/2 times the inverse sine of x. Now again, we know what the derivative is of the inverse sine. It was given to us. So off to the side here, let's remember that if y is the inverse sine of x, the derivative of y prime, or dy dx, is equal to 1 over the square root of 1 minus x squared. Let's take that back up here. H prime of x, we have a product here, two things multiplied together. So we're going to take the first and leave it alone, 1 minus x squared to the 1/2 times the derivative of the second. Derivative of the inverse sine is just 1 over the square root of 1 minus x squared, plus second, which is the inverse sine of x, second left alone, times the derivative of the first. Well, the derivative of this is going to be 1 half times 1 minus x squared to the negative 1 half, times the derivative of what's inside. Derivative of 1 minus x squared is a negative 2x. And there we have it. So let's rewrite it down here. H prime of x. Let's see, we're going to have the square root of 1 minus x squared times 1 over the square root of 1 minus x squared. That's interesting. Plus the inverse sine of x times, let's see, we got a 2 here and a 2 here divided to 1, and this is a negative exponent. It's going to drop to the denominator, so it'll be a negative x over this x here, over the square root of 1 minus x squared. So this is equal to 1 here, square root of 1 minus x squared times 1 over square root of 1 minus x squared. So we get 1 minus x times the inverse sine of x, all divided by the square root of 1 minus x squared. And there is h prime of x. Gets a little messy, but just stick with your rules and you'll be fine. Okay, I think you should be in good shape for your homework on 3.6. There might be 1 or 2 more problems in there that might throw you a little bit of a curveball, but just do the best you can, and of course ask me if you have any questions. 3.6 homework password is decimate, D-E-C-I-M-A-T-E, and that of course means to cause great destruction or harm to. Decimate is your word for 3.6. Good luck. Let me know if you have any questions.